Hello, everyone. My name is Krishnamurthy from QuantUniversity. And in today's presentation, I'm going to be talking about auditing considerations for ONNX models and benchmarking using the QuSandbox. Thank you again for the opportunity to present today. As you all know, as the complexity of machine learning pipelines have grown, people are talking about how do we assess risks in these models. And that's the problem we are focused on. We are a risk advisory based out of Boston, and we are focused on the intersection of data science, machine learning. And we have looked at a lot of algorithms, and we have audited a lot of algorithms. And one of the challenges we see is how do we take all these disparate components of models and pipelines and assess the risk comprehensively? To facilitate that, we are building what's called as the QuSandbox to enable risk governance and risk management of these models. And we are also part of LFAI. As a member, we have been able to get a lot of feedback from the community, and we very much appreciate that. In order to think about algorithmic auditing, one of the challenges is you have to make sure that there is a comprehensive effort to understand the various components which go into building these models. So in order to take this holistic view and kind of discretize it so that you can systematically think about an audit in a very comprehensive way, we have to make sure that we factor all the key components in a pipeline. And as you know, in a machine learning pipeline, there are various components involved, and the model being an important piece, but there are various other processes which are also extremely important as we build out these models. When we start building these models, there are so many choices. People can build them with enterprise products, with open source products, and the interoperability becomes a major challenge. And that's where a lot of industries are now thinking about using ONNX models for enabling that interoperability. Now, when we do an algorithmic audit, we look at various themes as a part of the puzzle, but let's kind of just focus on the model piece. And some of the considerations I thought which was important were things like, how do you benchmark a black box model with a white box model, which you have potentially developed? Are there going to be surrogate models you're going to be comparing against? What if a model was built using MATLAB, but then it's going to be tested in a Python environment? Or if it was built using another enterprise product and you're going to be primarily using open source within your workflow? How do you benchmark against a reference model which you're aiming to either be better at, or you're going to be thinking about performance metrics to be close to what the reference model is going to provide? How do you handle versioning? So if you are thinking about different versions of the model and making sure that you're testing them for different versions. What do you think about scalability, especially if your model is going to be deployed in an API environment, and then you have to factor in network latencies, and you also have to factor in data transfers between models? What kind of performance are you going to be potentially getting? And then how do you benchmark API behaviors when you think about APIs which are potentially going to be leveraging various cloud-based infrastructures? How can you factor those nuances within your environment? And then finally, the actual model testing itself. How do you stress test, scenario test, and what if analysis? So these are some of the things we look at as we kind of try out models. And in this demo, I'm just going to give you a big picture orientation on some of the things we do as a part of this assessment. So what you're looking at is a screenshot of the QuSandbox. And we take this holistic view and we break it down into individual components, depending on the importance of that particular audit and the key components that needs to be evaluated. And we have provided some of the tooling so that you can bring in some of these open source packages and try out various things in a development environment. But in the context of you reproducing some of these aspects in a Dockerized cloud-based environment, you'll understand like what are the capabilities of the model at a granular level, and then auditor can potentially go in and write reports on what they saw and where are the various areas wherein they could potentially enhance or improvise based on the model. So let me show you a live demo. In case you're interested to know more about the platform, happy to answer questions at a later point. But in today's presentation, I'm just going to give you a big picture orientation. So here what we have done is, as a problem setting, we have taken a simple MNIST model, which is an ONNX model available in a public repo. And we're going to be benchmarking against a Python implementation of the model and a MATLAB implementation of the model. And the goal here is, if you're going to be using these models in an API environment, how do we test it? And how do we kind of, factor your analysis, and how do you potentially audit these based on some of the considerations I mentioned to you earlier. So here, what you're seeing is is a summary board, if you will. As we kind of look at the summary board and we start looking at the code, so I'm going to show you, what we have done is we have taken the whole models, and we have created an API which will hit different API implementations. So one is our implementation in Python for an MNIST model. And these are ONNX model, which have been wrapped up in an API so that you can actually invoke the ONNX models themselves. And then we took another open source model from the TF Hub for TensorFlow, and we have used that as another implementation. So we're going to be comparing different implementations. So now that this is available as an API, so we have written a simple Jupyter notebook wherein you could potentially load the data set, and then this would be the original data set, and then we can hit the API and then get back the results and see how what the models actually displayed. And we have also extended an open source implementation of this model, which was they basically wrapped up the ONNX models, and we have extended that to incorporate our models and also a MATLAB implementation, so that you could go in and test out and compare different models and what kinds of results are you going to get when you look at these models. So from an auditor's perspective, you'd want to do various what-if analysis, and you will potentially also use this as a data generator so that you can try out different things and then generate different kinds of sample data sets so that you can try out what the model is going to potentially incorporate. So you can see that there are performance differences between the TF implementation and the ONNX implementation for these kinds of models. So this is a visual implementation. And then finally, when you run this Jupyter notebook, it generates reports, and you could potentially go in and then look at the actual reports themselves. And you can go in and edit the report and add your notes to it, and then you could kind of summarize the benchmarking of that particular report. So as I mentioned, auditing a model is a very involved effort, and there are various components to the puzzle. So in addition to the life cycle and the testing, there may be aspects of specific algorithmic assessments that need to be done. Security reviews may need to be done, especially if you're going to be evaluating security for a model. So there are a lot of considerations to be done. And I think having a comprehensive effort to benchmark different models and build a framework for auditing would help kind of understand the capabilities of different models and facilitate and foster the notion of interoperability and reproducibility of different models. I'll stop at that and take any questions. Thank you very much.